In this video, I will explain the moment of a couple. The definition of a couple is when two equal, parallel, opposite forces acting on an object are called a couple. It is when two equal, parallel, and opposite forces are acting on an object. Now, example of a couple in engineering or everyday life. When turning a water tap, you always use your thumb and finger in opposite direction when turning water tap, or when removing a bob cap, when turning a corkscrew, when turning a door key. You always turn it. You apply two equal forces that are equal and parallel but opposite in direction. When turning a screwdriver, that is an example of a couple in engineering. Now, you'll be calculating the moment of a couple in this section. Moment of a couple is given by the product of the magnitude of one of the forces and the distance between them. Now let's have a look at this activity from the textbook. The first activity, 2A, you are given there's a force of 40 newtons. This is 40. Distance is 0,2, 0,2, and that is 40. This 40 is equal to this 40. There are two forces. They are equal, 40 and 40. They are parallel, and they are opposite in direction. So that is called a couple. This one here, B, is still 40 and 40. 0,2, 0,2. Now, the fulcrum or the turning point is there at the end. Now, this is also a couple because these two forces are equal. They are parallel, they are opposite, acting on one object. That is a couple. Let's have a look at this one. This is 50 Newton, 50 Newton. They are equal. They are parallel. They are opposite. They act on one object. This is a couple. Have a look at this one. Last one. 80 and 80. They are equal. They are acting on one object. They are parallel. And they are opposite. So this is a couple. But if you are given forces like this, 20 Newton, 20 Newton, and the distance is 0,3 meters. This is not a couple. They are equal. They are parallel, but they are not opposite. So this is not a couple. A moment of a couple about any point is the same. If you want to calculate the moment of this couple about this point, you're going to get the same answer as when you calculate the moment about this point. It's still 40 and 40. What is changing is that turning point. So the moment is the same. Now, the shortcut to calculating the moment of a couple is to use this definition. Moment of a couple is given by the product. Product is the multiplication of the magnitude of one of the forces and the distance between them. In simple put, when calculating moment of a couple, the heading there is moment of a couple. M will be for moment equal to F multiplied by distance. It's a product of magnitude of one of the forces multiplied by the distance between them. This is how you calculate it. Now, not all the question will be asking you to calculate the moment of a couple. You can be asked to calculate the distance between these two forces, or can be asked to calculate the magnitude of this force. They are equal, remember. So you just need one magnitude of one of the forces and the distance between them. Let's have a look at this one. The moment of this couple will be, it take one magnitude. So it's 40 multiplied by a distance between them is 0,2 plus 0,2, which is 0,4. So it will be 40 multiplied by 0,4. Same applies here. Magnitude of one of the forces multiplied by the distance between the forces. Same applies here. It will be magnitude of product of one of the forces, which is 50, multiplied by distance between these two is 0,3. This is the distance between the forces. If you look at this one, it's given by product 80 multiplied distance between the forces is 0,5. So you take magnitude of one of the forces and multiply by the distance between the forces. So from that information, you can solve for the unknown. Let's have a look at this activity. It's taken from a question paper of April 2021. 2.4. A couple is formed by two 12-Newton forces applied at 30 degrees from the vertical. The distance between the forces from the point of application is 80 millimeters. Calculate the moment of a couple. I will sketch this. Is formed by two 12-Newton forces applied at 30 degrees from the vertical. So these forces, a couple, they must act on one object. Let me make 30, this is a vertical line. And let me make it 30 degrees. This is a vertical line. So from this line to this line, it makes 30 degrees from the vertical. This is a force acting on this object. Now, in order for this force or for this system to form a couple, I cannot apply this one in this direction. I also cannot apply it because if I apply in this direction, it will be same direction. They have to be opposite. I cannot apply it in this way because they must be parallel. So a force that is parallel and opposite to this one will be acting in this direction. And it has to make an angle of 30 degrees with the vertical. This is a vertical line, 30 degrees. Vertical line, 30 degrees. So these are equal. It's the same force that is F. They are equal, parallel, and opposite, acting on one object. Let's go back to a question. A couple is formed by two 12-Newton So the magnitude of this force is given as 12 Newton, 12 Newton. The angle is 30, the distance is 800. And let's go back to the question. Let's go back to the question, yes. When you calculate, the question says, calculate the moment of this couple. So moment is a force multiplied by a distance. So a moment is a turning effect of a force about a point. When you are given a nut here and want to turn it, applying a force there, that is downward, force F, this will be the turning point. So a moment would be a force multiplied by a perpendicular distance, which is F times S. Now, if you look at this force, this distance is not perpendicular to the plane. So that's why I first introduced you two components of a force. We have to replace this force with vertical and horizontal component. So when we close the triangle, we can close this side where the angle is. We're going to close it this way and this way. Also, if you close it this side, this way, and that way. Now, moment of this force. This is FC and this is FS. FC and FS. So FC, this is opposite side. It's going to take cos now. Opposite over, it's going to take sine. Opposite over hypotenuse. But if we close it this side, we're going back to where FC is taking cos. This angle is 30, this one will be 60 degrees. This will be opposite, so it's FS. And this will be adjacent, so it will be FC. This is angle is here, opposite. This is FS. And this is adjacent. This is FC. That's correct. So FS is going to take 12 sine 30. And FC is going to take 12 cos 30. Now let's go back to the turning effect. If you apply a force in this direction, a force that passes through the turning point, this force won't be able to turn the nut. In order for a force to have a turning effect, it has to be perpendicular to the plane. So if you look at these components, FC is the one that is perpendicular to the plane, but FS is parallel to the plane. So FS will have no turning effect about this point. Now, moment of a couple just need one force. We don't have to resolve this side. It's magnitude of one of the components multiplied by the distance between them. So the component that will have turning effect is 12 cos of 30 multiplied by the distance is given as 800 millimeter. So you have to change this distance to meters. It will be 0.8 meters. This is multiplied by 0.8 distance between the forces. And you use your calculator to get your answer. This will be 12 cos of 30 multiplied by 0.8, and you get the answer of 8,314. This is the moment of this couple. It's measured in Newton. This one is in meters. So a couple will be in Newton meter. That is the moment of this couple. So when a force is an oblique force, you resolve it. But if it is a direct force, you just take magnitude of one of the force and you multiply by the distance to get a moment of a couple. Thank you.